Hello, good evening. Welcome to our second development stream for April 2020. And yes, since we showed you the initial bits of the audio frequency node, or at least the basic development for it, we can now show you actually something that works. And if you remember last stream, we used a lot of audio that was kindly supplied to us by Steve Burke from Eggbox. Hello, Steve. And yeah, one day after this stream, he actually sent us a custom audio track to use with the audio node. And yeah, we are extremely stoked that we got this, and it's really great. And I assembled something today. I couldn't finish rendering it, but you can see the preview. And yeah, this is the official preview, or the official premiere of the tune written by Steve called db&w. So here we go. Okay, so that's not working. Apparently, as far as Dagmar told me, it doesn't actually make it across the stream. Let me just quickly check the audio mixer here to see if I can get it fixed. This is odd, very odd. Yeah, but I think that's actually my, if you can hear it low volume, then it's my microphone actually picking it up. Let me just check the settings here. Damn, I thought that worked the last time. Yeah, that wouldn't be good. Odd, I thought the capturing works. Maybe this one, let me just check. Okay, let's try this again and turn on my mic as well. So here we go. And let's just turn off the OpenGL user interface as well here. So yeah, that is the official premiere now with the audio. The file is stereo, but the plugin currently merges stereo tracks to mono for the for the frequency determination. It is a very, very cool tune. All right, so let's just clear the whole thing and start with something simple. Actually, I'll make it even simpler than this. I'm just going to add a null object, and I'm going to make it a shape, and that shape is going to be a sphere. So yeah, nothing special. Adding a motion nodal modifier. And if you're noticing, I'm actually using Lightwave 2019, mainly because I'm not sure if the real-time playback performance is quite there yet in Lightwave 2020. So yeah, I'm going to start this way. So we have a nodal motion here. And the only thing I want to do here is actually have that ball bounce with some audio. So let's just make this a bit smaller. And if, let's move this over there. All right. So basically I want the position here to be modified by the frequency of or the volume at a certain frequency. So the first thing I do is I go to the nodes, db&w, audio, and this is essentially the one that all the patrons got yesterday evening. I added a few things today, but it's basically the same thing. So there's the audio frequency node, and I'll just double click it to get the user interface. There we go. And select an audio file, and it's actually loaded already. And yeah, but let's just load that one from scratch so you can see what's happening. Ah, damn, wrong content directory. But here we go. Okay, it's smart enough to know that it's been loaded already. So if you load a new audio file, it opens the settings, which show you the waveform, and it allows you to select the FFT size, which is the size, the amount of samples used basically to extract the frequencies. I'll go into that in more detail later. So you have a couple of settings, and all of these settings are basically shared for every node that is actually using the audio file within your scene. I'll just exit that. And if you start scrubbing now, you will see that it already changes you can see this spectrum already. And it also tells you that the current file is a WAV file, 2 minutes 9 seconds long, which is 3,841 frames at the scene, which I think is 30 frames per second. Of course, the length in frames is going to vary from scene to scene, from frames per second to frames per second. And if it's actually not loaded in layout already, in this case it is, surprised that Lightwave doesn't actually clear that scene properly. You can click on use in layout and it will load it. Let me just actually start completely from scratch because this is no bueno. And I think I also need to remove a duplicate file here. Just give me a second. To be fair, 29.97 FPS is the most brain dead frames per second ever. All right. Where was I? Yeah, I think I have a duplicate plugin here because I changed the plugin file name. And that shouldn't happen. So let me just quickly delete one of them and then go back into Lightwave. 2019.1.4, there we go. Plugins. And yeah, this is the one I don't want. All right. All right, so let's try this again. Starting Lightwave. All right, null object, make that a shape, make it a sphere. Motion options, add a nodal motion to it, open the node graph, which is here, and then we're going to the audio section and the db&w tools, add the audio frequency node, and yes, this is actually a more current build because that shows a preview, even though it shows trash here, but yeah, it works. And if I open the user interface now and load an audio file, the only thing that could go wrong is that it's the wrong content directory. It isn't. Load the track, which is the BB master. All right, and this is what you get to see once you've loaded the audio file. You can change these settings here, but as I said, you don't really need to, but they're explained in the manual. I will not go into them right now, maybe later. And as soon as you're done, it computes the frequencies. As you can see, it's quite fast for a 2-minute file. And yeah, you can start playing with it. So, actually, I know that's 380 3,841 frames. So I'll set the last frame to be 3,841. And as you can see, it's not currently loaded in layout, the audio file. If I press use in layout, then it's going to be loaded into layout. And if you scrub it or play it back, we can hear it. We can see the frequencies here, and we can even see them in the node itself that was added today. There's still quite something missing there. But even if that user interface is closed and you're just looking at your node graph, you can actually see the frequencies change, or I think you can turn the preview. No, you can't actually turn that completely off, can you? No, you can just minimize it, but even then, it's going to be shown. Okay, so the options we have here is the use layout to load into layout. Settings gets you back to this panel. Currently, many of these things that I've planned here in the user interface aren't working. What is working is the single frequency mode, which basically means you get to pick a frequency, and the output of the node, this amplitude, is going to be the amplitude at that frequency, but it's normalized from 0 to 1, so you can easily multiply it and use it for whatever you want to. So if I basically just leave it as it is, the default frequency is 440 Hertz. If I now add a, I always forget the name, and it's my own bloody tool. A channel blender, of course. Add. So if I just take the amplitude, put that into the Y of a channel blender, take the vector, and put that into the position of my sphere, then the amplitude should be the amplitude of the music at 440 Hertz. And that in turn should change the vertical position of the sphere we've got here. And yeah, as you can see, if I play back, then it's actually going to move vertically just a little bit. Let me just turn the volume down of the audio track. Should be able to do it here. All right. So I can select different frequency. For example, if I want something that's a bit more bassy, like 50 Hertz, which is very low, and you will see that it's going to bounce a lot more because the bass is very pronounced in the track. So this is the mode that is currently available. You pick a frequency and it gives you the amplitude at that frequency. You can use it any way you want to. And even that by itself is quite powerful. You have the option to limit the decibels or the audio volume that you actually want to output. The default is 0 at the maximum because these are negative decibels. To minus 69, which is actually the signal to noise ratio that you have in 16-bit files. That's the maximum you have in there in terms of sound quality. I think 24 bits goes up to minus 120 decibels. And if you look at the spectrum up there, you will see that there's plenty of areas, or it's full everywhere. Even though you think cases there isn't that much audio. So one thing to actually get rid of essentially the lower volume noise is if you change the minimum level to something that's higher, like minus 60. And if I play it back now, you will notice that you have much more pronounced frequencies here. And what this basically does is it cuts off everything that's below minus 60 decibels and puts whatever is between 0 and minus 60 back into the range from 0 to 1. Oh, this is working already. Won't go into select, interpolate. I'll go into later as well. You can add a time offset if you want to, so you can delay where the audio is being evaluated in time. You can invert the output, which means that where it would normally be at the top, because it's a high volume, it's going to be at the bottom, and vice versa. And you can also boost it, which essentially just multiplies the output. So if I look at my sphere here, and you look at, let's move in a bit, you see that it's bouncing a little bit. If I change the boost to something like 500, it's going to be a lot more pronounced. Another way to do that would be to just essentially take the amplitude output and multiply it by something else. But this is just a shortcut because you're very likely to want to actually boost something. You have the respective nodal inputs for that. Frequency is the same as the frequency here. This is in hertz. You have a normalized frequency, and the tricky bit here is that the top frequency input, as I said, is in hertz. So for an audio file like that, it would need to be a value between 0 and 22,000. And if you just want like a full sweep across the whole spectrum from 0 to 22,000, you can just use normalized input and input a value between 0 and 1. And that helps if you, for example, would like to displace an object, a mesh, a plane, or something like that. So this basically takes a value between 0 and 1 and puts it into the range of the frequencies in the audio file, and it interpolates there. The spectrum normalized is very similar to that, except that basically the spectrum that you see here is not a linear spectrum from 0 to 22 kilohertz, but it's one that is essentially binned into different octaves, which are closer to the way that we hear audio. So there's an emphasis on the lower frequencies, while the higher frequencies are less pronounced. So whereas, if that was linear, then the middle frequency around here would be something like 11 kilohertz. But with the octave binning, you only get to about 1 kilohertz here, and from here to the end is from 1 to 22 kilohertz, but from here to here is from 0 to 1 kilohertz, and that's a lot closer to how we hear audio, where there's more of an emphasis on the lower frequencies. And the whole octave binning that I'm using tries to account for that. So if you use the spectrum input, then it's going to be much closer to what you expect to see from what you actually hear. Peak levels are they're planned, but it's something I'm going to add very, very late because there's still basic functionality that's missing. All right, so normalized frequency and spectrum input. You have the frequency range and the end frequency. Those are for different frequency modes. You have the minimum and maximum decibels input, which correspond to those two here. You have a time and a time offset, which corresponds to this, and the boost value, which corresponds to this. Now, what is planned is to not just have a single mode, but also a single and extend mode, where you can basically, where the frequency is going to be the center frequency, and you have a frequency range which is being subtracted and added to define an area or in the frequencies that you want to use, and you can then either average them or use the maximum. So if you're not exactly sure where the frequencies are that you would like to extract, then you can use something like this, and you will be able to actually do it graphically. So you can basically either up there or in a separate window just draw a rectangle, and the rectangle will determine these two settings, which is the center frequency and the frequency range. Or if you use the range mode, which is similar, this one uses a starting and an ending frequency, which is probably easier to use. And again, you will be able to select it graphically by drawing a rectangle here. Or press on select, which will eventually open a bigger window. And there you will be able to select the starting and the ending frequencies for a range, or just pick a single frequency for a range. And you can also change the minimum and the maximum level in that separate window. But that's planned, not done yet. And for the single and extend mode and for the range mode, you will also have an option to either, as I said, average the amplitudes or the volumes, or take the highest volume within that range and then only output that. Also, since, as you can see up there, you have very distinct frequencies that there's no graduation in there. There's some abrupt fall-offs. Interpolate will allow you to smooth those out, especially if you want to animate something like a mesh or displace a mesh. So this would be the essentially simplest use. Just take an item and let it bounce. Oh yes, you will be able to see what is actually currently selected. It's going to be a bit tricky if the values are animated or have an envelope on them, because as you can see here, these are actually enveloped, and if they're connected to if something is connected to the input, then you wouldn't be able to select something here either. So I'll have to take care of that, and probably actually selecting something if you have an envelope on any of those values should actually create keys. But yeah, you will be able to see the current range. And maybe this preview in the node will actually only show the selected range and not the whole frequency spectrum as it does right now. But we'll see. All right, let's go to the sample scene that I used as a teaser for this. That's exactly the next thing, Andrew. There is the audio node playing. Not even sure if that uses the same soundtrack. Does it? It should. Yes, it does. It does. So this is the sample scene that I posted yesterday, I think. And I showed you how the bouncing ball works. So you have a nodal motion, like this one. And in this case, I'm actually multiplying it for some reason because, oh yeah, I didn't have boost. Boost wasn't available when I did this. I think I added boost yesterday afternoon. Now, the interesting thing here is actually the displaced plane. If I go to the front face wireframe, you see it's a fairly dense plane. It doesn't really need to be, but it is. That's just one I had handy. And if we scrub through, yeah, you will see that you have the base on the left-hand side, the low frequencies, and the high frequencies on the right-hand side. And for that, we go into the object properties, and I have a nodal displacement here. Let me just clean this up a little because there are things that aren't actually needed. And even that, this might be, yeah. All right. So what does this do? Basically, what my main input is the current position, and in the displacement context, the current position is the current position of the vertex that you're actually displacing. So I'm getting that current position, and I'm putting it into a channel blender, so I can extract the x and the z coordinate. The x coordinate is this one, and the z coordinate is that one. Yeah, it's probably going to mess things up. It's too small now. All right. This doesn't follow my logic. See? Now I've messed it up. All right. So the x coordinate itself which is this. It's, I think, from -5 to 5. So what I'm doing is I'm remapping the the distance from -5 to 5 to 0 to 1. So the scalar value I get from this is 0 at this point of the mesh and 1 at this point of the mesh. And as you probably thought, this will go into the spectrum input, which is, again, expects a normalized value from 0 to 1. And if I just leave the time offset out, you will see that essentially what it does is displays like this. So I'm taking the x coordinate of the current vertex. I'm scaling it in such a way that it's 0 here and it's 1 here. I'm using that as an input for the frequency node, for the spectrum normal input. And I did also change the minimum decibels to -60 just to make things a bit more pronounced. And that is essentially all I do. I grab the volume of that. And I suppose this is the trickiest part. I multiply the, so I have to go back, the normal of the mesh at the current position with the amplitude of the audio frequency, and that in turn is being used as the input for the displacement. So I'm displacing along the normal, and the strength of the displacement depends on the amplitude of the audio file at the frequency that's determined by the x-axis. That's essentially what you see here. Now, to get that flowing effect, what I did is I basically took the z-coordinate, which is this one, and I think I added like a small value to it, 5, divided it by another value, -0.25, just to nudge it into something, and just use that as an input into the time offset. Now, all this does is, depending on the z position of the vertex, it changes the time offset where the actual, where the audio file is being evaluated. So at the beginning, I think this is 0, and this is like, I don't know, 5 seconds ago at the end, something like that. I could just probably pipe it straight in, but because the z position is from -5 to 5, that wouldn't work. So what I did is yeah, exactly. The original mesh is centered at the origin and has a dimension of 5 meters in every distance. So if I wouldn't add 5 here and just pipe it straight in like that, then the point where the current time is being shown would be the center of the mesh, which is somewhere back here. But I want it at the front, so I'm shifting it forwards by 5 meters. And then I'm dividing it by another value just to show more or less, make it slower or faster, essentially. So the add adds 5 meters so that the front of the mesh is where the current time is being displayed. And the divide basically, I think, gives me the amount of time that's being shown across the whole mesh. If I increase this to, let's make it -5. There you go. You will actually see that there is less, that it's showing less time, essentially. And if I play it back now, it's going to scroll a lot faster. Whereas if I turn this down, make it -1, for example, then it's going to scroll a lot slower. Also, what you can see here, you have some stepping in the mesh. Let me just turn off the time offset. you've got some kind of stepping here, you know, where the values don't interpolate smoothly, and that is because the interpolate option just isn't available yet. Once that is available, you will actually get a very, very smooth interpolation across the frequencies here. And yeah, so that's how I did that, and this is going to be one of the samples, of course, eventually. So yeah, that's one way to do it. You could, of course, if you take like a three-dimensional, I mean, a mesh that like a sphere is something that actually points in different directions. Since I'm actually displacing this along the normal, then you can have, you know, spikes produced from a sphere or something, depending on the frequency, and the frequency itself could depend on something else. There's plenty of noodling you can do with that. There is also going to be a simpler version of the node. One thing I need to think about is how to deal with stereo, because currently I'm just, you know, the amplitude is just the amplitude of the summed up signal, and it should probably have more outputs depending on how many channels there are in the original audio file. Yes, you can colorize that. I didn't do it here, but actually if we go to the instances, which I will eventually have to render out, go to a frame like that. Come on. All right. Ah, that's the original surface. Yep. This one is a little bit trickier, but possible. The problem here is that in the instance info, you only get the index or fixed random number. However, what I want is I actually want the ID of the current sphere that's being rendered, but on a range from 0 to 1, but in the right order, because I'm also applying the audio frequencies in the right order. So I know that it's, I think, 80 instances. So I'm taking the ID index, divide that by 80. That in turn gives me a result which goes into this normalized spectrum. I load the audio file, make it -60, take the amplitude and put that into the input of the gradient here, which looks like this. And now it's going to color them depending on the amplitude. Let me just add something in here to make that a bit clearer. 0.75, give it a nice color that sticks out, like, yeah, bam. And this one, actually, yeah, that needs to remain green, sorry. And then you put something in here as well. Turn that red, there we go. Yeah, and you will see that depending on the amplitude of that frequency, they get a different color. Ooh. And as for the instances themselves, oh, the instance is selected already. There we go. So I have an instancer here. It's radial, 80 instances, which is a number I have to actually remember because I need them for the shading. And I'm using nodes again. This time I'm using the fixed float, which is a number from 0 to 1, depending on which of the instances it is. Put that into a normalized spectrum. The node is the same as before, from 0 to -60 dB. It's the same audio file. I take the amplitude, again into a channel blender, just modified the y, which is the vertical distance, take the vector, and that's in turn goes into the offset of the instancer, which is this thing. The mode has to be uniform in that case. And since I'm also scaling the spheres up and down, all I'm doing is I'm taking the amplitude, which is between 0 and 1, and just directly pipe it into the scale, which basically means that the scale of the spheres is going to be between 0 and 100%. That's really all there is to it. And then the only other thing I'm doing is I'm actually rotating the instancer. And that's all you need to, for something like this. And, Steve was actually so kind to actually send us the different tracks of the audio file. So we have like the drums, the vocals, the synths, bass, everything. And you could essentially, make multiple concentric instances, and each one of them be driven by a different track from the tune. So yes, you can add multiple files. So multi-tracks would be multiple separate files, and there's going to be support for more than mono output. There will be stereo output. I'm not sure if the libraries that I use to actually load the audio file support more than two channels, but if they do, that is going to scale, certainly. So yeah, that is the current state. And this I really need to render out overnight and put it up on Facebook or something, because I think it's actually quite neat. So yeah, do you have any questions? I'll just see something pops up in the chat. And you don't need an excuse to use NodeMeister, just use it. But talking about NodeMeister, if any of you have missed it, look at our homepage at www.db&w.com. We have got a news item there about the upgrades for our plugins to Lightwave 2020. You can order them now. Because of some SDK changes between 2018, 2019, and 2020. We needed to have new binaries for Lightwave 2020 for all plugins, because there's some fairly basic changes actually in the SDK, and we can't pack them into the same binary, and those are available now on our website for a small fee. And for those of you that aren't patrons, we did send out the first build of the db&w tools that's available, that's compatible with 2020 yesterday. And at least for this year, we will make sure that the plugins that we send out do have a 2018 release as well as a 2020 release, so you get both depending on which version of Lightwave you're using. And the 2018 one is compatible with 2019. It's just 2020 that adds breaking changes. So yeah, that's your friendly service announcement, I suppose. So yeah, that's the current state. And I have to admit, I'm quite pleased with that myself. It's something I've always wanted to tackle for a long time. I've always been very, very scared of that whole fast Fourier transformation computation thing to get the frequencies out. And it did take some digging into, but yeah, it's working. And yeah, I know the frequency spectrum there in the node is just a gimmick, but it's so nice. It is so nice. All those colors. And if you look on our website, the wiki, you will see that I did write like some preliminary documentation already. This is actually needs a refresh because there's more. So I tried to document like the most crucial parts of it. Some technical background on how the computations work, how I do the binning into the octaves, even though it's something that shouldn't really concern the user. But if you actually want to know, have a look at that. Um, I mean, I tried to keep it as simple as possible, and maybe I will actually remove one of those frequency modes and just make it single and range and remove single and extent. That depends on your feedback as well. Um, and yeah, got some screenshots in there trying to explain the settings preferences. By the way, if this looks blocky, then it's because I'm actually running this light wave on this display at 150%. And I'm actually drawing the frequency bars at 2 pixel blocks to 2 pixel wide rectangles because initially I was drawing them as straight lines, which would work if you were running Lightwave at 100%. But as soon as you have like a higher screen resolution or screen density or DPI above the average or the normal, then it would actually have like small dark lines between them. So I had to switch from drawing lines to drawing rectangles. And so part of the blockiness here is on purpose, but also another part of that is because Lightwave is actually scaling all of this up by an extra 50%. And the same is true for the waveform here, and the same is also true for the node. Because in neither of these allow me to actually draw in the native resolution. It's just this virtual 100% resolution, and then Lightwave scales it up to the screen density. So yeah, and yeah, the selection is going to be like that frequency panel that I showed on last stream, something along those lines. Thanks, Steve. Yeah, now the problem is just to rein in the features into something that doesn't overwhelm too many people, because I can understand that it might be super complicated for some. I'm even thinking of having a second one that's just called audio, which like gives you a preset audio volume and then like bass, medium frequencies, high and too high frequencies, just something like that, so you can whip up something quickly. And if you actually need more control, that's when you start to use the audio frequency itself. And the simple one could then also be like the base for the channel modifier, which we will need if we actually want to apply any of this stuff to a channel in the graph editor. We will need to have something here. And the interesting thing is also that the audio files here, they're only used once or only loaded once and can be reused multiple times. They will all share the same settings because all the frequencies are cached in memory, but that in turn also allows me to use them for surfacing, because surfacing requires tons of evaluations per image, where something like a motion just requires 1 or 2 per image. And yes, so all the values are cached, and the caches are shared between different plugins. So just having a channel modifier and a couple of nodes that will all use the same audio file and the same cached spectral values. The delay is a time offset here. Also, one thing that I think I've used that in FrameD. This time offset actually has a dual use. If you just enter a value here, then it's going to use that single value as an offset. But if you envelope it, then it's actually a proper time envelope that gives you the absolute time. And it doesn't offset the current time, but if you envelope it and you have it like at frame 0 at 0, frame 0 at 0 and frame 100 at 2.5, then this means that at frame 0, it's going to evaluate second 0 of the audio file. And at this frame 100, it's going to evaluate second 2.5 of the audio file. It doesn't offset it anymore. This is going to be the absolute time. But that's also explained in the manual. I think I'm going to limit the frequency modes and just have single and range. I mean, those settings here, granted, I could just, put some of those at hide them or something and just use the defaults that I think make more sense. But, who knows, there might be a borderline case where somebody would like to have more control. I might just remove this floor value here, though. That's not really that useful, especially since you can change it using the minimum decibel levels here. Yeah, the interpolation is also going to reduce the flickering effect. Also, one thing that shouldn't forget is I've been running this in real time here using OpenGL, and that is going to add some delays and flickers and stuff about as well. Difficult. One thing that would ease it if you have once you've got the range frequency mode and you can use a range of frequencies and then use the average of that, then that is kind of going to smooth things out as well. But any other kind of smoothing would actually have to take the change in time or the change over time of a volume into account, and smooth that out using some kind of curve function. And that would mean not just looking at the frequencies of the current frame, but also looking at some frequencies of the next and the previous frame, and then fit those or put like a Gaussian curve on top of those just to smooth things out, and that would also make things a lot slower. Whereas the interpolation itself is just going to look at the frequencies around the current frequency and maybe look at the frames around the current frame, but not further than one. And that should help. Also, one thing I'm doing right now is these frequencies. I mean, this is essentially what's being cached per frame, what you see there. It's just a different representation of it. That might be, I don't know, a couple of hundred values per frame that are being cached for the frequencies. It's per frame because that's kind of the smallest unit where it makes sense. If you do motion blur, it might not blur between two frames at the moment, might not blur properly because the values aren't interpolated, and that is going to be activated with this as well. Where was I going with this? Oh yeah, one thing that is also mentioned in the manual already is since the cache is per frame, if you actually change the frames per second, then you will have to recalculate the cache. There's just no way around it because I have no way to determine if the frames per second has actually been changed by the user. As far as I know, there's no command for that. I have to check that I could intercept or something. So basically, if you do that, on a scene that you've loaded that already has audio files loaded into it, then you would have to go to the settings and recompute all, and that's all there is to do, just so that the caches take the current FPS into account. I think as far as using it, this is like the biggest possible problem that could probably show up that isn't that obvious. So yeah, the interpolation should solve some of those problems. And I think, let me just put this away and go back to the plane. I would really need to analyze the audio file and check what BPM there is in it. And to be fair, I'm not sure how to do that. I mean, I'm happy enough that I got the FFT and the frequency analysis to go. I'm not sure how BPM is being computed, and from what I have seen, even from some professional tools, it looks like it's more or less kind of eyeballing it between a bunch of values. So yeah, I don't see that happening. But what I do want to add is a way so you can just get the basic waveform as an output as well. So not just the frequency, but let's go in here to nodal displacement. So you don't just extract the frequencies, but you can also get something like this as an output value. Because I've got the waveform in memory anyhow. I am storing this as well. So you get the basic waveform, but you also get the extracted frequencies. I've even seen, some professional tools that, I mean, they're always like, this is 120 plus minus 1 BPM or so. And many seem to have problems there as well. So I'm not going to tackle that. So yeah, basically the two interpolation problems that you have here is you have the horizontal one, which is the values between frequencies that you're sampling. And you have the vertical one, which is along time, where it's also a bit, I suppose, stepped, because you only have like, one value per frame, and you might have, as you can see here, just see if you can zoom in there. You've got something like that, where this is the distance from one vertex to the next is exactly one frame, and I can interpolate a long time as well. I might make that just a second option or so. Is it that time of the day already? Well, apparently I've got some friends in the States that are howling in the streets. So hey, maybe clapping is the better option. Then again, my last name is Wolf, so maybe I should move there. So yeah, and I mean, you do have the basic plugin already. What I'm going to do is I will MP3 the audio track that we got from Steve, which blew us away. So thank you again. And I'll MP3 that and upload it to the demo content. And the link to that is in the mail that all the patrons got. It's always the same directory, and I'll just update it there and put the MP3s in the sound directory by tomorrow. And then if you would like to play with that and would like to have some music to play with, now you've got the music to play with. And the only thing you have to do in return is show us what you've done. No, it's not a competition. But yeah, I'm really having a blast with this. This is good fun. Wish I had more time to actually play around with that in Lightwave. But yeah, it looks like there's plenty of stuff to code, plenty of things to do. So yeah, that's really all I can. Oh yeah, you can do the voice track as well. Yeah. You mean MP3 artifacts? I doubt it. I doubt it. It's probably just going to be, slightly shifted audio spectrum or something. But I don't think it's going to be that bad. I mean, you still have the main frequencies in there, and as far as I know, MP3 does use a psychoacoustic compression model, which might, swallow up some frequencies that are hidden by other ones by the way we hear. But I don't think it's going to affect the generated spectrum that much. Well, the good thing is you can play already because you do have, well, not exactly this version, but the one before that, which works already. And yeah, the audio files will be up by tomorrow, promise. Oh yes, we definitely want to see it and hear it. So yeah, I think that is it, unless you have any more questions. Obviously, next week there is not going to be a poll for a new plugin because this is the second month of this one. Maybe I can think, or we can think of other stupid questions to ask you, but it won't be about the plugin. And yeah, that's one reason why I wanted to get something out before this as well, so you actually have something to play with. We are going to take a break from this for the next week, work on some other stuff. But by that time, you should have had the chance to look at that as well, come up with ideas, and bombard us with suggestions. And then next month we can, wrap this up, trim it down, remove all the stuff that doesn't need to be in there, make it as simple to use as possible, make it as beautiful as possible, and yeah, wrap it up. So yeah, on that note, wrapping it up, I think is a good way to end this. So thanks a lot to all of you for joining up. I'm not even sure how many people have been on the stream, but yeah, thanks to all of you. Hope you enjoyed this. Hope you enjoyed the plugin. If you're not a patron yet, look at the link in the video description. Become a patron, support us, and stay safe. Wash your hands. And as Dagmar said, if you have any of our commercial plugins in Lightwave 2020, don't forget to get your updates. And on that note, have a good one. Bye-bye.